Hi, this is Sean Ritchie from Fire Security. We're here today with our good friend Reto from Latin America, who looks after
Hey,
everything
how you
for
all
us.
going?
We're going to be talking about structural steel fireproofing or structural steel fire protection today. So without me yabbering on and wasting everyone's time, as I usually do, let's get down to it. So I will move our screen along if I can. No, it's not going to do it. Yes, it does. Okay, right. So Fire Security Systems supplies several versions of thin film passive fire protection for structural steel.
Sean,
Yep.
sorry to interrupt at the beginning already, but if you say thin film intumescent, what does really thin mean and how do you calculate that?
What thin really means, well, an intumescent grows by expansion and insulates a structural member. So the good thing about intumescence, not unlike our FS15 11 cable coating, which is an intumescent, they're all thin film and low build coatings. So they only require 1 to 2 coats, maybe 3 coats, and usually all are under the 5 millimeter film thickness, dry film thickness. You can have high build or thick film coatings. A lot of the epoxies for hydrocarbon applications are high build. They can be up to half an inch to 3/4 of an inch in thickness. They can still be intumescent too and expand, but they expand for a greater rate of a fire curve or a higher fire of around 1100 degrees Celsius. So a thin film coating is really clearly what it states. It's thin. It can be anywhere from 400 or 300 microns up to 5 millimeters. So to your second part of the question, how do we determine our thin film coatings, or how do we determine the thickness of the coating in itself, is relied basically on what's called a HP/A or M factor, which is basically a section factor concept. And the section factor is a very important concept when using passive fire protection on structural steel work. The section factor, or HP/A, is the ratio of the fire exposed perimeter of whatever member it's supposed to be, whether it's a column or a beam or an I-beam or a square hollow section, rectangular or circular, to the cross-sectional area of the steel. So essentially it is a measure of how quickly the steel section will heat in a fire. So that is your HP/A factor. So essentially it is the measure of how quickly that section will heat in a fire, and therefore determining that HP/A factor will give us a factor of how much fire protection coating is required for that section. And what you find is very large sections, large steel sections, have a very low HP/A value because it takes longer for them to lose their integrity. The smaller the section, the larger the HP/A, so then it has a extremely thick coating put onto it, because that small section is going to lose its integrity. So a low section factor equates to a stocky section, which when unprotected will take longer to heat to a set critical temperature than a relatively slender section, which is a high section factor. The inherent fire resistance of a stocky section or a big section therefore requires this section to have less fire protection to achieve the same fire resistance rating. So that's why you will find on our certificates, for instance, that you will have a HP/A value and you'll have a dry film thickness next to it. So, and that will equate to, once we, or our estimators, work out the factor of that steel section within the plans or the specification or the scope, we will give you that section back with a dry film thickness plus a spread rate to achieve that dry film thickness.
And how do you measure the fire exposed perimeter?
Well, that's the heated perimeter. It's an equation of heated perimeter over the cross section of the steel itself. So it's a calculated equation. So you'll take the heated perimeter, every ounce of perimeter of that steel section, and that steel section could be attacked by fire by all four sides. If it's a column, for instance, if it's a beam, it could be a non-load bearing beam, so it could still be four sides. Or it could be a three-sided because it's got a slab on the top of it. So you're only protecting three sides of the beam, or even two sides if it's against a wall and a slab. So there's varying degrees of what your HP over A will actually equate to.
Okay.
And a lot of the times you'll find that even steel manufacturers nowadays produce the HP over A factor on their steel charts. And if not, you will find the cross-sectional area factor on the steel chart, and then you have to equate the heated perimeter, whether it's a 4, 3, or 2-sided version, to calculate that out. But the good thing is, the most happy thing that we can offer is that we do it all for you. So all you have to do is provide us a steel schedule of fireproofing. And or a drawing with all of the steel that's going to be fireproofing or carry fireproofing, and then we'll do all the calculations and send you back a full chart, including pricing and everything else. So really, you've got we would supply, or our estimation team would supply you a full quotation plus an estimated chart showing you the film thickness per beam, spread rate per beam or column, right down to the nth degree.
Wow. Okay. Thank you.
No problems. Okay, so back to our first slide, yeah? You hit me with a lot of questions all at once. So we have, excuse me, we have 4 versions of structural steel coating, soon to be 5 with a hydrocarbon coating, but I'll get to that a bit later. So please remind me before we finish.
Yeah.
So we have FS 370, FS 460, 470, and 490. All 4 are thin film coatings for the protection of structural steel up to 120 minutes or 2 hours. And each of these members, 370, 460, and 470, British Standard approved, 490 is UL approved.
I see on 470 and 490 no indication if it's water-based or solvent-based.
Okay, so, well, if you look on the page we've got up now, you'll see FS370E and FS370I. E is for exterior, I is for interior.
Mm-hmm.
Both the 370s are solvent-based fireproofing. No water. Their base is solvent. The base is actually xylene. So if it needs to be cut down or it needs to be a solvent added to the pile, you would add xylene up to 5% maximum dilution.
Right.
So and then the 460 and 470 are water based, British Standard approved. FS 490 is water based, UL approved.
Okay.
All 2 hours. 460 is our 60 to 90 minute rating for British standards. So the 370E, as we see here, 2 hour fire rated solvent based thin film for exterior structural steel. And you utilize our FS84 top coat. And the FS84 top coat's sort of, you're talking microns in thicknesses once the FS370 is fully cured. It's only there to seal the system and to color it as well. So the FS84, we can not only add the top coat, but we can add a color to that coat, to any RAL color code, and then you can not only seal the system but completely color it as well.
Okay. Question, do all those intumescent coatings start reaction at the same type of temperatures?
Yes, they do. Yes, they do. They all run the 80 to 90 degree mark. That's when they actually start to activate and start to protect.
Okay.
Celsius, sorry, too. So our 370E, 370I, sorry, is our indoor solvent-based thin film coating. It doesn't require all indoor coatings. They don't require a top coat because there's no moisture content that's going to get to them. There's no water, so all of those, although all of those fireproofings, usually if they're not hidden behind a wall and they are shown on the steel work, they will be coloured. So, but that can be just the standard interior paint, commercial paint, latex or acrylic. There's no issue. So we get asked regularly, though, one of the questions about our interior coatings is that do we need a top coat to protect and seal it? Should it be an extra coating of paint on it? We just don't concern ourselves. Once the fire protection coating, the whatever FS coating it's going to be, interior, has cured, we don't care what paint's on top of it. Of course, a water-based paint, not a solvents-based paint. But it'd be a water-based paint of any colour, any description. Doesn't matter if it's Taubman's or it's whatever brand. It really doesn't matter, and it's not really our concern once that fireproofing is fully cured.
Understood.
So our FS460, which is British Standard approved as well, 60 to 90 minutes fire rating, water-based for interior. FS470 is our 2-hour. FS470 also has 60 and 90-minute ratings too, but depending on what element or what column or beam it is, we play between 460 and 470 to give the client the best option when it's under the 2-hour rating. So it can be an either or.
What is the difference between the two of them?
In reality, the ratings itself. The 460 being the 60 used to be just purely a 60-minute rating. So anything from 60 and under we would use 460, and anything from 60 and over we would use FS 470. We've had several tests of FS 460 that have gone to 90 minutes. So now it's a 60 to 90-minute rating, but because the brand name or the brand name of FS 460 has been around for a while, so therefore we're not going to change it. But we can carry 90 minutes on some sections for the 460. The 470 is the golden boy of the I would dare say, of our whole range, though, because it does such a huge, vast amount of cross-sectional sections and coatings, and it runs for its 2-hour rating. So we get to our FS 490, which is our UL approved 2-hour fire rating. For structural steel for North America and for other parts that do require a UL rating above British standards. But what you will find, and I haven't got this on the presentation, but what you will find is that the ISO fire curve, which is used primarily in Asia and Europe and the Middle East, and also South America, is actually a higher burning, longer burning fire curve than the ASTM fire curve that UL uses. So in first appearances, our 460 and 470 and even 370, and which we do have a full engineering letter for this, show that if we test our 370, 460, 470 under ASTM or UL fire curves, then that would be an acceptable level as well. So we do have an engineering letter that we can always forward out in case someone is incorporating and wants a UL approval. The film thicknesses are vastly different between British standards and UL. Much more economical and much more cost effective to use a British standard fire curve than a UL or ASTM fire curve. And you'll see that by the film thicknesses within themselves.
Okay. So if someone wants to use like FS470 for a UL-approved type of application, you will provide an engineering letter for it?
Yes, we've already got one. We've already got an engineering letter that clearly states that if our British standard approved, so 370, 460 and 470, if they were tested under the ASTM fire curve based on the experience they've had with the ISO fire curve, which burns higher, then that they would clearly be tested in a positive mode.
Okay.
So, steel coatings within themselves. Our coatings, they're an intumescent coating that can be applied to a flange beam and column, hollow section and other various steel sections, whether it be plates, square hollow sections, rectangular, circular. There's a varying amount. And with every amount of steel, even a plate has a HP over A value to it, where it would be the heated primer over the cross-sectional area. There's always a calculation to a piece of steel. Our fire ratings are up to 2 hours for internal and external steelwork. Intumescent coatings expand up to about 800% to form a protection layer. So not unlike our FS11 cable coating, which is intumescent as well, they protect through insulation. Under fire they expand out and then char off over a period of time, protecting the substrate, whatever the substrate would be. And in steel coatings, obviously it's steel, but that's how it, non-technically works, I think would be the best description. And as I said, it protects by forming a non-combustible insulating protective layer that eventually chars off over a period of time, and then would hit its failure point of its designated tested time. Extremely strong but durable coating with no formation of cracks at all. There's no reinforcement required. A lot of the coatings on the market need a reinforcement on the flange edge of their beams, or sometimes the wraparound circular hollow sections. You would spray.
How do you reinforce those?
Well, usually after application of primer, you would put one coat of your fireproof coating on the section, and then it's usually it's called mesh reinforcement, but usually it's fiberglass mesh, very flexible, and then you would just roll that in to that coat and press down. And what that does is that usually traditionally a lot of intumescent coatings for steel would crack on the flange edges. That's where they traditionally crack through movement, and that reinforcement stops that cracking. So you would put a light coat down, you would roll in the mesh reinforcement, and you'd put a top coat down over the top of that, usually about half the thickness. If your thickness was 2 millimeter dry film, you would put around 1 millimeter down, then reinforcement, then another millimeter, and then you would be complete, and that would stop that cracking. And a lot of our competitors' coatings still have that. Luckily, we don't have that at all. There's no need for it.
Okay,
no problems. So that stops the cracks on our competitors. We don't have that cracking issue because of the flexibility of the coating. Although it's extremely strong, it's still a very flexible coating. All our coatings, all the steel coatings are off-white in colour. We usually get asked 1 in 10 times if we can colour the fireproofing. We can, but you can pretty much guarantee that you're going to be putting a decorative coating over the top anyway. So there's no real need to do that. But we can do it in any circumstance. But usually when you're looking at producing a special batch with a special colour, it's going to cost a lot more for the end user. So they're better off still just putting a decorative finish spray coat over the top anyway, after full cure. And that leads straight to the next point. So it's a standard top coats can be applied after full cure, whether they're latex or acrylics. Externally, you do need, we obviously prefer our FS84 top coat over the top of our 370 if it's an external application. But any UV, 100% UV, 100% waterproof urethane, locally manufactured will do. But we can't guarantee that's not going to that's going to adhere or not. So if anyone wanted a guarantee, then it would have to be fully tested first. But we know our FS84 is tested against our product. So also our water-based coating, FS470 and FS460 also carry LEED approval. So I think we discussed this with the FS15.
Yes, we did.
That's right. So they carry no VOCs whatsoever, no chemical content whatsoever, off gases, it's non-toxic, non-hazardous, LEED approved, so third-party approved, no VOC. So we can put that in green buildings, and that's coming to prominence quite regularly now, especially in North America and Europe. Everything has to be built green. So therefore we can put that product in quite comfortably because we do have a third-party certificate for that.
Yeah. If you say full cure in the point of the ball, how long does that take? Fully cure?
Full cure, absolute nutter full cure, it can take up to 30 days.
Wow.
You know, you've got...
So you can only apply the top coat after 30 days?
Pretty much. Because you don't want to leave any room to stop that to stop the fireproofing from full cure. So if you're putting a coating over the top, you can trap it, and you don't want to trap it, especially solvent-based coatings.
Okay, and how do you establish when it's fully cured?
Well, you can do a hammer test, but usually by 30 days it has reached its full cure zone. Really, it's only about 23, 24, but saying 30 days is always a very safe time. But you're not going to be doing your external fireproofing in the rain and then thinking it's going to fully cure either. Most of that fireproofing would be done undercover.
Humidity is a factor as well.
Humidity can be we would prefer relative humidity. If it's a high humidity, it's going to take longer to cure off. But low humidity, sort of the Middle East countries where they're very low humidity and high temperature, they're cured very, very quickly. Sometimes too quickly if it's too hot. Sometimes if it's so hot that you can't even spray the product properly because it's curing in the lines of the machine. I have seen that happen at 45 and 50 degrees Celsius. But then again, you'd be mad to be spraying that outside anyway. So, but it does happen. But it happens everywhere with every type of coating. If the temperature is simply too high, you cannot spray it. You can't spray it. Especially solvent-based, no issue. Solvent-based aren't curing. The water-based, yes, they are. The water-based coating, the water is evaporating at that sort of temperature before it can even get sprayed on.
So you do not have the issue with the solvent-based ones?
No, and even the solvent-based ones, you can do it under zero. Because there's no freeze-thaw issue with the coating because the solvents because it's solvent-based. There's no water content whatsoever.
Right, but you still will need to wait 30 days, or is that quicker there too?
No, I would always, regardless of application of where it is, I would always wait that 30 days as a full cure time. I mean, it's tack dry in 24 hours, and within 48 hours, it's got a skin on it. But if you're looking at 3 or 4 millimeters in dry film thickness, you've still got a period of time where that thickness under heavy coat has still got to cure out. So you've got to let it get to its full hardness, and 30 days is its full hardness.
Right. You mentioned the hammer test. Could you expand on that?
Well, a hammer test is basically for exactly what it is. You hit it with a hammer. I know
and what you try to see with it?
Well, you want to see if you can split it. Or it's doughy. What's a better word for doughy? If it's still soft to a degree. I mean, you can, there's even fingernail tests. You can scratch the surface of it. You can also do those sort of things. And if it's not fully cured, that will sink in. Once you breach the surface, once you the upper crust, if you want to call it something like that, once you breach that surface, you want to see if you can get to the bottom of the steel. And obviously, if you do a scratch test, it's a very easy patch up because you're only patching that section. But yeah, you can either do a hammer test or a scratch test or a surface scratch test. and that will see the cure rate.
Okay.
So with our thin film coatings, what we've found through a lot of cross-sectional work with other suppliers, that our film thicknesses are extremely thin compared to the competitor, especially at 120 minutes. In some instances 30 to 40% thinner. So achieving, and this comes back down to even what we discussed in our first seminar with FS15 cable coat, the less product, less freight, less storage areas, all of those things impinge not just on getting the product to site and spraying the product, but there's less product to spray, less man hours, less costs. So there is a lot of incentive to be looking at these types of coatings. And you see that by the end run. You see that by the finished quantity of product and the total product used per square meter. I could put basically on this presentation the same slide that we discussed with our FS15 of how to measure product. A lot of the same things that we get with our cable coating, we get with our steel coating, where people simply ask for 5 or 6 pails of coating. And I always ask, well, we can definitely supply you 5 or 6 pails, but what are you spraying? How did you determine your film thickness? Yeah. With cable coating, it's very easy. There's one defined film thickness. With steel coating, every steel section has a different film thickness. Every steel section. So, and it's an engineered system, so it needs to be double checked. Otherwise, if you've got a very small section and you're only putting 0.5 millimeter of fire protective coating on it, it's not going to do the job. It's not thick enough to stop that steel section from losing integrity.
So the thickness also per section actually will vary between the FS products and the competitors' products?
Oh, vastly, vastly. But what we find nowadays, there's a lot of sections for us against one competitor that out of a ratio of HP over A's from bottom to top, I think they have one better film thickness than us, and we were talking probably 50 microns, all the way up to one of their sections is 3.5 millimeters thick, and we're 2.1 millimeters thick. We're 1/3 of their section, and a millimeter in on an overall 10,000 square meter project is a lot of difference in product.
Mm-hmm.
So
a similar chart on here as you had on the other one, as you say.
Yeah, well, that's not a bad idea. I think I will develop that. It's very similar in itself. To you can run an average of steel sections to an average of coating thicknesses, which will give the customer a good idea of where they're heading with that pricing. But you have to provide, because steel coating is an engineered system with defined film thicknesses based on that steel section. We need that steel section to understand what you're trying to protect, how long you're trying to protect it for. So if for instance, you came to us and you wanted to have a quote, we would need either the fireproofing steel schedule, which is all the steel to be fireproofed, whether it's an internal application, an external application, the steel itself, not only the section but the length of section, so that can give us our overall square meters, and whether you want it to, if you're going to install it, which we'll now discuss, which is erected after erection or pre-erected. Now, pre-erected steel is that when it's sitting in the blast area and it's just been primed at the shop, we can come in, or our installers can come in and spray that steel while it's on the floor. It's not erected in its structure. That's a very economical, very, very cost-effective solution because there's no scaffolding needs, there's no on-site requirements. We come straight to the shop, we spray all the fireproofing onto the steel. It's fully cured when it leaves. If it's a water-based coating, we would put a protective FS84 top coat layer over it just for travel, because it might sit on the road for 7 days in rain. So that intumescent interior water-based coating needs to be protected. So what we would do is you would spray all of the steel in the shop, then it would be transported to site, then it would be erected after fireproofing's been done, and then as an installer would come in, and then they would patch up the bolt areas, they would patch up the plate areas, the scratch and scruff marks on the fireproofing, and bring it back up to speed. You know, and that's and it's still a more cost-effective solution to do it that way than it is to do it already installed.
Yeah.
So for the application of the materials, you can put it on by brush, but like we discussed previously with other coatings, this is a decorative. The thin films are traditionally known as decorative finishes. So you want it, if it's going to be seen, you want it to be an extremely nice surface, and you can really only achieve that nice surface but with spraying, and that can be a Graco 33, 44, 56 to 1 airless spray machines. Usually with these types of materials, you only need up to about 3,300 psi in your machine, and you can get these. You can get those from Graco for plug-in. They're just plug-in and spray. They're not compressor driven. They're electric driven.
Mm-hmm.
So on top of, like we also discussed, there's no protective top coats required for the interior use. In its wet, dry, or under fire stage, there's no toxic gases, acids, or fumes that come from
That's
the...
also for the solvents, for both solvent and water-based?
Yeah, well, see, that's everyone thinks that because it carries solvents that when it burns, it's going to be there's going to be an off gas or acids or fumes. Actually, once the solvent-based coatings carry solvent in its wet form only. Once it's fully cured, it carries no solvent.
Okay.
So, for instance, the best determining factor, I think, is when you're looking at a water-based coating that carries 75% solids. So it's 75% solid, 25% water. Same with the solvent base. It's 75% solid, 25% solvents. Well, after cure, it's only 75% 75% solids. There's no solvents left. It's all offed out into the air when curing.
All right.
And like we discussed about testing the if it's in full cure, it has extremely good mechanical resistance. If things are banging into it like a truck or something like that, of course it's going to chip off, but then you can easily replace it because it's a homogeneous product. Once it's cured, you can come back and top over the coating itself in a damaged area, and it will cure to itself.
Mm-hmm.
So why do you use steel coatings? For structural steel and structural integrity, to continue it up to, well, I've got 120 minutes here, but up to its designated rating. You might have steel work that you only need to be 30-minute fire rated, up to 120 minutes fire rated. You want to protect your staff and your assets being the building, and whatever's in the building too. The 120 minutes rating is that you also want to get the people out of that building, and then there's no loss of integrity within the structure for a period of time, so everyone's going to be out. You can design and incorporate steel into the overall aesthetics of the building, so the steel can be seen now instead of hidden behind walls or hidden behind that old cement that you see in the car parks, which is a cementitious-based fireproofing. It looks horrible. It's never finished properly. It's meshed out and very time-consuming, but it's a huge eyesore. But with the thin film coatings, it just looks like paint. Once, and as you can see in the photo right here, that's a completed surface without paint on it. That's just the fireproofing. So you can still see all the sections, the welds, So you can see all of that, and the end user or the consumer, when he walks into a building, is pleased by the steel because he can see it and it's fireproofed, and they don't even know it's fireproofed. Also, with the thin film, you can use it for because of the low DFT for space within walls. A lot of the time, steel is covered up, but because of the square footage or the square meterage of rooms and everything else, basically the drywall has got to be or the board has got to be pressed up against the steel. Well, a lot of the time you don't have space to put a cementitious base product there, which might be 25 millimeters thick, or a special board or anything else. So putting a low dry film thickness intumescent coating, which could be 1 or 2 millimeters at the most, is the perfect solution.
Yeah.
So as we discussed, we also have the interior-exterior application, which is very, very good. Not many people have exterior fireproofing coatings, so they're very rare. As we discussed before as well, low DFT means less product, less weight, less cost for transport, and less cost for the end user.
Yeah. That's good.
So if we look to the approval sections, UL 263 is FS 490. So that's our UL rating, UL 263, 2 hours. That's our only UL rated steel coating. The ASTM E119 runs for the UL 263. So FS 490 is the only North American approval, I guess you could say. For the 370, the 460, and the 470, they're all BS 476 Part 21, 1.5 hours and 2 hours, internal or external. And our no VOC lead approval green build for 460 and 470. And what you will find across the world, that's all it is ever required. But we're always keen to test more if required and if need be, especially if a customer requires us to do a test for them. We're more than happy to move forward that way as well. Okay, so just to give a brief idea, the application, I've got FS15 cable coat instead of steel coating. Of the steel coating, you'll see here what we have is the primer, which is typically either an epoxy or a red or grey oxide, usually locally purchased. We do have primers available as well, but they're epoxy primers. But usually by the time we get to the structural steel sections, it is already fully determined what that primer is going to be, and a lot of the time that steel is already cut and primed. So what we would require at least is a data sheet and an MSDS of the primer, so we know that there's not going to be any adhesion issues. And usually, that's right, and usually we want non-zinc primers.
Okay.
All of the grey and red oxide primers, which are 95% of the world primer base, are all non-zinc based. So you'll get the steel pre-primed. We'll place the fireproofing on it by brush or by spray. By hand, unfortunately, I have seen it put on by hand on smaller sections, and it is not a good look. But mainly, if it ever is done by hand, then it's done in a section where it's not going to be seen. And then after full cure time, then we put a top coat on. Whether we supply the top coat or the top coat is supplied locally.
Okay.
So that gives us a very brief run through of our steel coatings. And at least a brief understanding of what they are and what they're for.
Thank you, Sean.
No problems. What we'll do is I'm redeveloping as we go these presentations, and when we get the new steel coating presentation done, we can run through that again if you like.
It sounds good.
No problems. Well, thank you very much for listening to me.
Well,
Much
thank you.
appreciated. And I will see you soon for our fire stopping presentation.
That should be tomorrow, right?
I think so.
All right.
Okay.
Take care. Thank you very much, Tom.
Thank you.